All right, solutions for written problem 5. So this one, not a whole lot of creativity going on here. All that you are asked to do is create your own unit circle. And by a unit circle, what I mean is something kind of like what you see pictured down below, with 16 special, for lack of a better word, points. And what you need to know about those points is both the angle in degrees and radians that leaves you at those points, and the x and y coordinates of those points. So in this video, I'll go through and I'll fill in all that information and maybe also give a couple of hints pretty quickly about how I remember all those values. So for me, the color coordination certainly helps. I'm going to start with these points in blue here. You'll notice that they're each a quarter of the way around the circle, and since all the way around the circle is 360 degrees, and a quarter of 360 degrees is just 90 degrees, it's easy enough to figure out the degree measures that leave me at these points. Since I measure in the clockwise direction from the positive x-axis, I'll start out down here at 0 degrees, in which case up here is 90 degrees, over here is 180 degrees, and down here is 270 degrees. And if you wanted, you could continue and put 360 degrees over here, but I'm not going to. I'm going to leave it just as what you see here. What I'll do next is I'll focus on the points in green. And the idea for the points in green is they are 1/3 and 2/3 of the way in between the points that you see in blue. So since 1/3 of the way from 0 to 90 is 30 degrees, if you include the blue and the green points together, all you gotta do is count up by 30 degrees as you go around the circle. What I'm saying is this point right here corresponds with 30 degrees, and this point 60 degrees, and now as long as I include my blue for the 90, I can add 120 degrees over here, 150 degrees over here. Again, hitting this blue is 180 degrees, so that moves me up to 210 degrees, and 240 degrees down here in the third quadrant. There's my 270 degrees, which means that this must be 300 degrees, and this is 330 degrees. And a nice built-in check is if I added another 30 degrees, I'd get back to 360 degrees, which I know is coterminal with 0 degrees here. Finally, the points in red, their defining characteristic is they're halfway in between the points in blue, and since half of 90 is 45 degrees, I can do the same trick that I just did, except instead of counting by 30 degrees, I count by 45 degrees, as long as I include the red and the blue points. So what I'm saying is if I start here with 0 degrees, this would be 45 degrees, and if I add another 45 degrees, that gets me up to 90 degrees. Another 45 degrees would get me up to 135 degrees, another 45 is this 180, another 45 is 225, another 45 is 270, and my last 45 gets me up to 315 degrees. Again, we have this built-in check where if we added 45 degrees more, we'd get up to 360 degrees, which we know, again, is coterminal at this point. Okay, so those are degrees. What about radians? Well, I'll do kind of the same trick. I'm first going to fill out the blue and then figure out the greens and then the reds. So for the blues, the idea now is instead of counting up by 90 degrees, because 90 degrees is a quarter of all the way around the circle, which is 360 degrees, what I'm going to do is I'm going to count up by pi over 2. Why pi over 2? Because pi over 2 is a quarter of 2 pi, and 2 pi is the distance all the way around the circle. So if I start out with 0 radians here and add that pi over 2 to 0, that gets me up top here. Adding another pi over 2 to pi over 2 gives me 2 pi over 2, in other words, pi. Adding another pi over 2 gives me 3 pi over 2. And a nice built-in check, if I added one more pi over 2, I'd have 4 pi over 2, which is just 2 pi, which is one lap around the circle. Now that I have those, I can fill in the points in green. Remember, greens were 1/3 and 2/3 of the way between the points in blue, but I don't want to be thinking about the points in blue in terms of their degree measure. I want to be thinking about them in terms of their radian measure. So just like I came up with this 30 degrees by taking 1/3 of 90, I'm going to come up with pi over 6 by taking 1/3 of pi over 2. And this will be the number that I continuously add as I work my way around the circle. So 0 plus pi over 6 is this pi over 6. Another pi over 6 is 2 pi over 6, which you can reduce to just pi over 3. And then that 2 pi over 6 plus another pi over 6 is 3 pi over 6, which is this pi over 2 right here. And then adding another pi over 6 to that gives me 4 pi over 6, which I can write as 2 pi over 3. And then that 4 pi over 6 plus another one gives me 5 pi over 6. Here's 6 pi over 6, 7 pi over 6, 8 pi over 6, which I would write as 4 pi over 3, 9 pi over 6, which I'd write as 3 pi over 2, 10 pi over 6, which is 5 pi over 3, and then finally 11 pi over 6, with the built-in check that if I added one more pi over 6, I'd get 12 pi over 6, which is just 2 pi. Similarly, the points in red. Red is halfway in between the blues, so instead of thinking about 45 is halfway from 0 to 90, think about pi over 4 is halfway from 0 to pi over 2. What I'm saying is this point right here corresponds with the radian measure of pi over 4, and that's what I'm going to add as I work my way around the circle, considering only the points in blue and red. So if I start here at 0, a pi over 4 gets me here. Another one is 2 pi over 4, which I can reduce to pi over 2. and then 3 pi over 4, and then 4 pi over 4, 5 pi over 4, 6 pi over 4, which I can write as 3 pi over 2, 7 pi over 4, and then finally 8 pi over 4 would be 2 pi, and that's my check that I did everything right as I went around the circle. Okay, cool. I have all the angles in both degrees and radians. What about their x and y coordinates? Well, let's start with the low-hanging fruit. The points in blue are pretty easy. The x coordinate over here is 1, and the y coordinate is 0, and that's because this is a unit circle, so its radius is 1. And if I go a distance of 1 straight to the right from the origin, I have an x coordinate of 1 and a y coordinate of 0. If instead of going right 1, I go up 1, I would have an x coordinate of 0 and a y coordinate of 1. If I went left 1, I would have an x coordinate of -1 and a y coordinate of 0. And if I went down 1, I would have an x coordinate of 0 and a y coordinate of -1. Well, there's things you can do other than memorization. I think for the points in red, it's probably easiest just to memorize. These are the root 2 over 2, root 2 over 2 points. What I'm saying is both their x and y coordinates are going to be the square root of 2 over 2. However, you do have to be careful about the sign of these two coordinates. Are they positive or negative? Well, up here in the first quadrant, everything's positive. But over here in the second quadrant, my x coordinate is negative while my y coordinate is positive. So instead of root 2 over 2, comma root 2 over 2, I would have negative root 2 over 2, comma root 2 over 2. Same idea down here in the third quadrant, except in the third quadrant, both the x and y coordinates are negative. So I still have these root 2 over 2 ideas, except they're both going to be negative. And then in the fourth quadrant, I've gone to the right, so the x coordinate is positive, and down, so the y coordinate is negative. So I get positive root 2 over 2, negative root 2 over 2. All that's left are the points in green. The points in green are the ones that maybe you're thinking root 3 over 2 and 1/2. But it's hard to remember which one has the x coordinate of 1/2 and which one has the y coordinate of 1/2. I think the easiest way to get there is just visual inspection. If you look at this point right here, its x coordinate is not 1/2, because if I went straight down from here, I'd end up ballpark here, which is nowhere near halfway in between here and here. Its y coordinate, on the other hand, looks like it's about 1/2. This point right here would be about halfway from here to here. It looks like the y coordinate of this point is 1/2, and therefore the x coordinate of this point must be equal to 1/2. If these are the 1/2s, then their remaining coordinates are the root 3 over 2s, so the first quadrant of my unit circle is completely filled out. I can use this information to fill out the remaining coordinates. This point right here, for example, has the same y coordinate as this point. Their heights are the exact same, so it's going to have a y coordinate of root 3 over 2. Its x coordinate, however, it's not to the right, it's to the left, so instead of being positive 1/2, it's going to be negative 1/2. Oh yeah, that makes sense. Up here in the second quadrant, the x coordinates are negative and the y coordinates are positive. Oh, and if I know that I've used up my 1/2, negative in this case, as the x coordinate here, it must be the y coordinate down here, and therefore the root 3 over 2 must be the x coordinate. But be careful, up here in the second quadrant, the x coordinates are negative, so I must put a negative right here. Same logic down here. This point and this point are really similar. In fact, they have the exact same x coordinate. So this negative root 3 over 2 is what I'm going to write for the x coordinate down here. And therefore 1/2 must be its y coordinate, but be careful, it's not positive 1/2, it's negative 1/2. And that's because down here in the third quadrant, both the x and the y coordinates are negative. If I've used up the root 3 over 2 as the x here, the root 3 over 2 must be the y down for this point, and the 1/2 is the x. But again, careful on the signs, everything's negative down here in the third quadrant, so I tack on a negative here and here. Finally, this point, I don't know, maybe I say its x coordinate is the same as this point, so the 1/2 goes here, and therefore the 1/2 would go here for this point, leaving me with only the root 3 over 2s as the y coordinate on this point and the x coordinate on this point, and then go back and double check your signs. Down here in the fourth quadrant, the x coordinate should be positive, as we saw here, and the y coordinate is negative, so this is root 3 over 2, negative 1/2. This is 1/2, negative root 3 over 2. I think this was all the information that was required of you. However, I said up here in the prompt that including the tangent values was optional. So I'm going to include those maybe in purple or whatever color this is here. Again, low-hanging fruit, let's start with the points in blue. The tangent is always the y coordinate divided by the x coordinate. So it's this 0 divided by this 1, and 0 divided by 1 is just 0. Another way you can get there is the tangent is the slope of the line connecting the origin to that point. So if I drew a line from here to here, it would be a horizontal line, and a horizontal line has a slope of 0, hence this 0 here. Same logic for this point. I can either take its y coordinate, which is 1, and divide it by its x coordinate, which is 0, and get something that is undefined. Or I can consider the slope of the line that connects the origin to this point. It's a vertical line. A vertical line has an undefined slope. Same logic gives me a 0 over here, because 0 divided by -1 is 0, or the slope of a horizontal line is 0, and undefined down here, because -1 divided by 0 is undefined, or this vertical line has an undefined slope. Okay, what about the points in red? Well, if I take this y coordinate and divide it by this x coordinate, anytime you take a number and divide it by itself, you get 1 as the answer. Oh yeah, that makes sense. The slope of this diagonal line is just 1 here. Same logic gives me a positive 1 down here, because this negative root 2 over 2 divided by this negative root 2 over 2 gives me a positive 1. Similarly up here, if I take a positive and divide it by a negative, I get -1. And if I take a negative and divide it by a positive, I get a -1. I filled in the tangent for all these points in red. All that leaves are the points in green. You can get there a few different ways. You can get there mathematically by taking, I don't know, this y coordinate and dividing it by this x coordinate. But what I think is easier is kind of memorization-y, just to remember that the tangent of these 2 points, one of them is the square root of 3, and one of them is the square root of 3 divided by 3. And how are you going to keep straight which is which? Well, if I take the square root of 3 and then divide it by 3, I get a smaller number. And since the tangent just talks about the slope of the line from the origin to that point, and I can see visually that the line from here to here has a more shallow slope than the line from here to here, the tangent at this point must be less than the tangent of this point. So this one must be the one where I took the square root of 3 and divided it by 3, whereas this is the one where I just have the square root of 3. Over here, since I'm dividing positive and negative numbers, my answer should be negative, and because the slope of this line is the same as the slope of this line except it's negative, this should be negative root 3 over 3, and this should be negative root 3. Down here in the third quadrant, where my tangent is positive, because a negative divided by a negative is a positive, the steeper of the two lines has a slope of the square root of 3, and the shallower of the two lines has a slope of the square root of 3 divided by 3. Just like over here in the fourth quadrant, except over here in the fourth quadrant, we're going to have negative tangents, because a negative divided by a positive is a negative. Negative root 3 here, and negative root 3 over 3 here. Those are all of the values you'll want to have memorized off your unit circle, as well as a little bit of logic about how I remember these values. If you want more detail, go back to the videos that I made earlier in this section where I derive all these guys. What I had in mind for this video was kind of coming up with these values as quickly or maybe as easily as possible. Hopefully that's helpful to you.